next topic we're going to look at is the quadratic formula. So, the quadratic formula is useful when we're trying to solve a quadratic equation and it can't be factorized. So it can work on ones that can be factorized, but it's especially helpful for those that cannot. So there is a proof of this on page 49 of your workbooks, and I'm not going to go through the proof of it, but we're just going to go over the formula and then look at how to apply that and use it. So the quadratic formula looks like this. X is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a, where our a, b, and c come from the quadratic. So if it was in the form ax squared plus bx plus c equals 0, that's what we can apply. So when it's in that form, then we use the a, b, and c from it and sub it directly into this. So let's do a few examples where I would sub it in. So for our first example, let's say we had x squared minus 5x plus 2 equals 0. And I want to factorize this. So normally I would look what adds to negative 5 and multiplies to 2, but I can't think of anything. So let's try applying the quadratic formula and see how that works. So we get negative b, and in this case b is negative 5, so I'm subbing it in like that. So negative b plus or minus the square root of b squared, so that's negative 5 squared, minus 4 times a, and in this case there's nothing in front of the x squared, so there'd be a 1, times c, which is 2, all divided by 2 times 1. So simplifying this down, I get a negative and a negative make a positive, so I get 5 plus or minus the square root of, so negative 5 squared is 25, and then I've got minus 4 times 1 times 2, so that's minus 8, all divided by 2. So I get 5 plus or minus 25 minus 8 is 17 over 2. And they're not very nice numbers, but we can verify our final answer. So what I would want to do is go 5 plus 17, I would go 5 plus the square root of 17, all divided by 2, and then the other answer will be 5 minus the square root of 17, all divided by 2. And if I use my graphics calculator to verify, go into equations, polynomial degree 2, and I enter in the original 1, negative 5, and 2, and solve, I get an answer of 4.562 or 0.438. And those would be the two answers to this. Let's do another example like that. Maybe they're not all to one side yet, so maybe you have 2x squared equals 5x plus 12. So I want to get everything to one side first because we want it in the form ax squared plus bx plus c equals 0. So I get 2x squared minus 5x minus 12 equals 0. Subbing into the quadratic formula, so I get negative b, and in this case that's negative 5, plus or minus the square root of b squared minus 4 times a times c all divided by 2 times 2 this time. So x equals 5 plus or minus the square root of 25. Now this time I have a negative and a negative, so that becomes a positive. So 4 times 12 is 48, times 2 is 96, so it's plus 96, all divided by 4. So x equals 5 plus or minus 96 and 25 is 121 divided by 4. And the square root of 121 is 11, so that's a nice number. So x equals 5 plus or minus 11 over 4. So if I plus 5 to 11, I get 16, and 16 divided by 4 is 4. Or I minus it from it. 5 minus 11 is negative 6, so that would give me negative 6 over 4, which would simplify to negative 3 over 2, or negative 1.5 if you like. Now I know you can just stick these onto your calculator, but when you do an actual assessment, there will be a question or two that says use the quadratic formula to solve. So you'll need to do that. So I'd like you to try the questions on page 50 and 51 and see how those go for you.